Hi, everybody. This is Professor Ken, and this is Math 111, Week 3. Today is September 7th, and I'm going to teach you everything you need to know to be successful in today's lesson. So first, I'm going to share my screen. All right, the screen is now being shared, and here's today's PowerPoint presentation. So these are the slides for this week. And quick review, whenever we have two fractions set equal to one another, it's called a proportion. So notice x over 2 is a fraction, 6 over 12 is a fraction. There's an equal sign in between, so that by definition is a proportion. And it's two fractions set equal. So how do we solve? We cross multiply. So when we cross multiply, we have x times 12 is 12x. And 2 times 6 is 12. So we have 12x equals 12. So of course, x equals 1 because 12 times 1 equals 12. So 1 over 2 equals 6 over 12, and we know that. Why don't you try this one? All right, so if we cross multiply, we get 14. It is not letting me draw. Okay, hang on a second. Oh, now it's there. Okay, so we get 14 equals 6x. Then we want to get x by itself, so we divide both sides by 6. And we get 14 over 6 equals x. But we want to simplify that. So we'll divide the top and the bottom by 2. And we'll get 7 over 3 equals x. And if we want to make that into a mixed number, 7 divided by 3 is 3, with 1 is 7 divided by 3 is 2, with 1 left over. So the leftover goes in the numerator, and the 3 goes in the denominator. So x equals 2 1/3, or 7/3. All right, here's something new. All right, what do we hate about this problem? You guessed it, we hate that there's fractions. So we can get rid of them. And we do that by multiplying both sides by the least common denominator. So the least common denominator of 10 and 15 is 30. And throw the x in there. So the least common denominator of all three of them is 30x. So what's the least common denominator? Well, 10 is 2 times 5, 15 is 3 times 5, and x is just the x. So it will be 2 times 5 times 3 times x, and of course that is 30x. Now we multiply both sides by 30x. So there's our original equation. Notice we're multiplying both sides by 30x. So if we do 30x times 1 over 10, we'd get 30x over 10, but the zeros cancel out, so we end up with 3x. If we do 3x times 15, 30 divided by 15 is 2, so we end up with 2x. And if we do 30x times 1 over x, the x's cancel out, and we get 30. So we would end up with 3x minus 2x equals 30. 3x minus 2x equals 30. So 1x equals 30, or x equals 30, because 3x minus 2x is 1x. All right, so there's a little neat trick for you. Okay, why don't you try this one? Okay, so I'm going to go to my pen, and hopefully it'll work. All right, so the three denominators are x, x, and 2. So the least common denominator, that's the number that all of them can be divided evenly into, is 2x. So we're going to take that 2x, put it over 1, and multiply the whole thing by 1 over x plus 2 over x equals 9 over 2. Okay. When we multiply 2x times 1 over x, what happens? X's cancel out, and we end up with 2. Bring over the plus sign. When we multiply 2 over x times 2x times 2 over x, the x's cancel out, and we have 2 times 2 is 4. And then when we multiply 2x times 9 over 2, the 2's cancel out. So we have x times 9 equals 9x. So we end up with 6 equals 9x. Let me bring it up here. To get x by itself, we divide both sides by 9. So we have 6 over 9 equals x. Simplified by dividing top numerator and denominator by 3. And we end up with 2 over 3 equals x. So x is 2/3. Perfect. Let's move along here. Another proportion problem. Okay. Now this one has 2 terms in the denominator. Those are called binomials. All right. So we cross multiply. So we do 9. Get my laser. So we'll do 9 times x plus 2 is 9x plus 18. And we'll do 11 times x minus 2 is 11x minus 22. So 9 times x plus 2 equals 11 times x minus 2. Distribute the 9 and we get 9x plus 18. Distribute the 11 and we get 11x minus 22. So combine like terms. Okay, what I did was I took away 11x from both sides and we get negative 2x plus 18 equals negative 22. Now I'll take away 18 from both sides and we'll get negative 2x equals negative 40. Now I'll divide both sides by negative 2 and we get x equals 20. Okay, notice that it works. So if I put 20 in here, 20 minus 2 is 18. 9 divided by 18 is 1/2. So this side is equal to 1/2. Put a 20 in here. 20 plus 2 is 22. 11 over 22 is also 1/2. So we get 1/2 equals 1/2. All good. Okay, you try this one. So we'll have 3 times x plus 1 equals 4 times 2x minus 1. Now that'll be 3x plus 3 equals 6x minus 4. So I distributed both sides. Okay, let's take away 6x from both sides. And we end up with negative 3x plus 3 equals 6x minus 6x is 0, negative 4. Take away 3 from both sides. And we end up with negative 3x equals negative 7. And divide both sides by negative 3. Easy algebra. And we end up with x equals 7/3. Perfect. You guys are doing great here. So we can apply proportions to work problems. Notice a basketball player makes 8 out of 12 free throws. If she shoots with the same accuracy in the second game, how many free throws will she make if she attempts 15? So we'll make 2 ratios and set it equal. That's a proportion. So we'll have made over attempted for the first game equals made over attempted for the second game. So for the first game, she made 8 and attempted 12. For the second game, she made M because we don't know how many she made. We got to figure that out. And she attempted 15. So 8 over 12 equals M over 15. We'll cross multiply and get 8 times 15 is 120 equals 12M. Divide both sides by 12 and we get M equals 10. So if she makes 8 out of 12 and then she tries 15, she's going to make 10 of them. So she makes 10 free throws in the second game. All right, now chemical mixture problems. These are a lot of fun. A solution contains 15 milliliters of hydrochloric acid and 42 milliliters of water. If another solution has the same concentration of hydrochloric acid and water, then how much hydrochloric acid is in 140 milliliters of water? So we go HCl over water equals HCl over water. So the first solution has 15 milliliters of HCl and 42 milliliters of water. The second solution, we don't know how much HCl is, that's the unknown, but we have 140 milliliters of water. So we have 15 over 42 equals X over 40. So if we cross multiply, we get 2,100 equals 42X. Divide both sides by 42, and we get X equals 50 milliliters. So we have 50 milliliters of hydrochloric acid in the second solution. And notice why that makes sense. So get my laser pointer going. In the first solution, we have 42 milliliters of water and 15 milliliters of hydrochloric acid. That's almost 1/3 of the water. So almost 1/3 of this water would be about, 50. So our answer completely and totally makes sense. Let you try this one. A 6-ounce serving of grapefruit juice contains 159 grams of water. How many grams of water are in 20 ounces of grapefruit juice? So we're doing grams over water, and water is H2O, just for simplifying. So in the first juice, we have 6 ounces of juice over 159 grams of water. In the second one, we have 20 ounces of juice, and we want to figure out how many grams of water. So we have 6 over 159 equals 20 over x. Cross multiply, 6 times x is 6x. 20 times 159, it'll end in a 0. 2 times 9 is 18, regroup a 1. 2 times 5 is 10, plus the 1 is 11, regroup a 1. 2 times 1 is 2, 3. Now we'll divide both sides by 6. And we'll get x equals, 30 goes into 6 5 times. And we'll have to regroup a 1. 6 goes into 18 3 times with no remainder, and 6 goes into 0, 0. So if I want to do long division, 180 divided by 6. 6 goes into 31 5 times. 5 times 6 is 30. Subtract 1, bring down the 8. 6 goes into 18 3 times. Multiply 18. Subtract 0. Bring down a 0. 6 goes into 0 0 times, no remainder. So it's 530 grams of water. Easy peasy. Okay. So why don't you try this one? Well, 2 times 7 is 14. 6 times x is 6x. Divide both sides by 6, and we get 7 over 3 equals x. Pretty easy. Okay, rate problems. Okay, in order to solve rate problems, we need to understand rates. So rates have the word per, and the word per means divide. Don't ever forget that. Per means divide. So a car travels 60 miles in 3 hours. The rate is 20 miles per hour, because we take the miles 60 and divide by the hours 3. 60 divided by 3 is 20 miles per hour. A basketball player makes 8 in 24 attempts. The rate is 8 baskets per 24 attempts. Divide both sides by 8, and we get 1 basket per 3 attempts. Or we could say 1 basket, yes, 1 basket per attempt. 6 ounces of juice has 180 grams of water. We say that the rate is 30 grams of water per ounce of juice. 4 inches on a map represents 200 miles. We say that the rate is 50 miles per inch, because 200 divided by 4 is 50. All right, today we're going to do motion rate problems and work problems. So motion rate problems. It's important to always make a table. If you don't make your table, it's not going to work. All right, now laser time. All right, so the formula is rate times time equals distance. Sometimes we'll know the time, and sometimes we'll know the rate and we'll know the time. We multiply them to get the distance. Sometimes we'll know the time and the distance, and in order to get the rate, we do the number in the third box is always the numerator, and the other number we know is always the denominator. And sometimes we'll know the rate and the distance, and to find the time, the third number is always the numerator, and the other number that we know is the denominator. So rate equals distance divided by time. Time equals distance divided by rate. Distance equals rate times time. Those are the 3 formulas. So what's the rate in miles per lawn? No, in hours per lawn, if Hector mows 3 lawns in 9 hours. Okay, so Let's get the pen going here. All right. We don't know the rate, but we know that he mows 3 lawns. That's the number of jobs. So in a work problem, rate times time equals number of jobs. So he did 3 lawns. That's the number of jobs, and the time is 9 hours. And as we said before, the third number is always the numerator, and the other number we know is the denominator. So it's 3 lawns in 9 hours, and that's equal to 1/3 lawns per hour, or we could say 1/3 lawns. We could write per like that, per hour. Either way is correct. Good job. 3 lawns, 9 hours, 3 lawns per 9 hours, or 1 lawn per 3 hours, or 1/3 lawn per hour. Okay. Motion rate problem number 1. A car is traveling 60 miles per hour. That's the rate for 30 minutes. Now we know 30 minutes is half an hour, so that's the time. How far did the car travel? Take a look at this. The rate is 60. The time is 1/2. 60 times 1/2 equals 30, because half of 60 equals 30. So the rate's 60. The time is half. The car travels 30 miles. All done. Motion rate problem number 2. Shakira rides her bike on an average of 30 miles per hour. There's the rate. How long will it take her to ride 150 miles? That's the distance. Now we got to find time. So her rate is 30 and her distance is 150. To find the unknown in the first or second column, make the third number the numerator. Okay, so take a look at this. So 150, the third number is the numerator, 150. The other number is the denominator, 30. So we get 150 over 30. We can cancel out the zeros. Cancel out the zeros, and we get 15 divided by 3 is 5. So her time is 5 hours. Fabio flies his airplane a distance of 300 feet. It took 15 seconds. What's the plane's rate in feet per second? Distance is 300 feet. Time is 15 seconds. Remember, to find the unknown box, the third column is the numerator. Okay, so we know the distance is 300 feet. We know the time is 15 seconds. So the rate is the third number divided by the other number. 300 divided by 15 is 20. So the rate's 20 feet per second, because feet is in the numerator, seconds is in the denominator. Oops. All right. Tina is training for a triathlon. She bikes 81 miles. That's a distance. Her rate averages 27 miles per hour. That's a rate. How long, in other words, how much time did it take her to bike 81 miles? Okay, we're going to do this on our own. So we'll make our box. You should be trying this too. You can pause the video and you try it. So we have rate times time equals distance. All right. 81 miles is the distance. 27 miles per hour is the rate. The time's going to be, well, the third number is the numerator and the other number is the denominator. So 81 divided by 27 is 3. And what's the time? Miles per hour. So it's got to be hours. And there we have it. Oh, I guess I did it for you. Let me see if I can erase all the ink on the slide. Okay. Oh, just made the chart for you. Okay, here's another rate problem. In order to, we did this already. Okay, hold on. Okay. We did Tina. Okay. Now, sometimes we're going to have to add our times together. Okay. So sometimes we have two rates, and either the times are given and we add the distances, or the distance are given and we add the times. Let me show you what I mean. Tyrone is training for a bike race. He rides 15 miles, excuse me, up a hill and 15 miles back down the hill. So his total distance is 30. The trip took 2 hours. The downhill speed was 20 miles per hour faster than the uphill speed. How fast does she ride uphill? Well, it should be he. Okay, so we have uphill, downhill, and total. We don't know what his rate is uphill, so we'll just put R. But we know he rides 20 miles an hour faster downhill, so that's R plus 20. We know the distance going uphill is 15, and the distance going downhill is 15 because it says he rides 15 miles up the hill and 15 miles back down the hill. And we know the total trip took 2 hours. So what's the total distance? 30. And what's going to be the rate? Well, remember, the third number is the numerator, and the other number is the denominator. So the average rate is going to be, the rate for the entire trip is going to be 15. So we have to figure out what R is. So the time is 15 over R. And this time is 15 over R plus 20. But here's what I need you to know. Okay, this time plus this time will equal 2 hours. So that's how we make our equation. So we solve, we say the time uphill plus the time downhill equals 2 hours. So here we have it. 15 over R plus 15 over R plus 20 equals 2. Now remember how we got rid of the fractions. We'll multiply both sides by R times R plus 20. Or we could just go to Desmos. So watch this. You're going to like this. We'll let Y equal 15 over R plus R plus 20. And we'll find out when all of that is equal to 2. So we want to know when all of this is equal to 2. And Desmos will help us with that. So we'll use X instead of R because that's how Desmos does it. So look what I did. Okay, I'm going to use my laser pointer. So the first thing I did was I typed in 15 over X plus 15 over X plus 20. And then I put, I graphed it over here, and I found out when it was equal to 2. So the whole thing is equal to 2 when X is equal to 10. Or in other words, when R, that's the same thing as R, so when R equals 10. So let me show you what I did on Desmos. Okay, let me pull up Desmos here. So we're going to go to www.desmos.com. Go to the graphing calculator. And we'll say, we'll type right in here, Y equals 15 over X. And then I hit my cursor key over there, plus 15 over X, and then 15 over X plus 20. So let me go back to there, plus 15 over X plus 20. Now I want to figure out when Y is equal to 2. So that's, here's where Y is equal to 2 right here. So I want to go over here and find out what this point is right here. It's got to be exactly 2. Okay, so we could see that. I'm having trouble getting exactly there. There it is. So when X is equal to 10, R is equal to 2. So the X value is 10. Now we can go back to our PowerPoint and start solving it. So since X is equal to 10, that's the same thing as R. How fast did she ride uphill? 10 miles an hour. How fast did she ride downhill? 10 plus 20 is 30 miles an hour. And that's how we solve that. So there's our equation. Go to Des. Okay, did all that already. So there's our Desmo. All right, so let's try another one. A boat travels 30 miles up the river in the same amount of time it takes to travel 50 miles down the river. The current is 5 miles per hour. Traveling upriver equals R minus 5 because the current is 5, and traveling down the river is R plus 5. What is the speed of the boat in still water, R? All right. So up the river, we're going 30 miles. Down the river, we're going 50 miles for a total of 80. Up the river is R minus 5. Down the river is R plus 5 because of the current. So we're trying to figure out what is the speed of the boat in still water. We're trying to figure out what R is. Okay, and the key is same amount of time. So remember, the numerator is 30, the denominator is R minus 5. For this box, the numerator is 50, the denominator is R plus 5. And since it says the same amount of time, these two are going to be equal. So the times are equal. We set the times equal to each other and we go to desmos.com. So in the first graph, we have 30 over X minus 5. And in the second graph, we have 50 over X plus 5. Then we see when they're equal. Okay, let me go to the Desmos and show you. So it's 30 over X minus 5, 50 over X plus 5. So in the first box, we'll say Y equals 30 over X minus 5. And in the second box, we'll say Y equals 30 over X plus 5. Now we want to see when they're equal. So I need to go over here and let's open it up a little bit so we can see where they cross. So here the blue line is on top. Blue line is still on top. Keep going. Let's shrink that down again. Looks like it's right around here where they're equal to each other. So we'll say at 50. That's close enough. Okay. Sometimes estimating is good. Okay, so they're equal to each other at 50. Hang on, did I do something wrong? Oh, this is supposed to be 50. I'm sorry about that. Okay. I knew something was wrong. Okay, so now we see right here, they cross when X is equal to 20. So let's look over here. 20 minus 5 is 15. 30 divided by 15 is 2. 20 plus 5 is 25. 50 divided by 15 by 25 is 2. So they cross when X equals 20. All right, so going back to our table, we know that R is equal to 20. And what does it say? What is the hang on. Okay, so R is equal to 20. So now we'll go back to our table. Okay, we know R is equal to 20. What is the speed of the water, the boat in still water? 20 miles an hour. So going up the river, he's going 15 miles an hour. Down the river is 25 miles an hour. Still water is 20 miles an hour. I'm not going to give you anything that hard for homework. Okay. But here's one I would like for you to try, because I think you can do this one. So special from current slide. Okay. One car travels 300 miles in the same time it takes for a second car to travel 5 miles per hour slower to go 275 miles. What are the speeds of the car? All right. So we make a rate times time equals distance table. The distance of the first car is 300. And in the same time it takes the second car traveling 5 miles per hour slower. So his speed is 5 miles an hour slower. The first car is R. And the second guy's going 275 miles. What are the speeds of the car? So what we need to do is solve for times here. This time is going to be 300 over, the total distance is 575. This time is 300 over R. This time is 275 over R minus 5. And we want to find out when they're equal. Or we want to solve for R. So these two are equal because it says in the same time. So 300 over R equals 275 over R minus 5. Make two equations in Desmos and go ahead and solve it. So there we have it. And we see that R is equal to 60. So another way to do this is we could just set the two equal to each other and it makes a graph and it solves it for us. Okay, work problems just like motion problems. Rate times time equals the jobs completed. This is pretty easy. Suppose that one painter can paint the entire house in 12 hours. It's right here. And the second painter takes 8 hours. That's right here. How long would it take the two painters to paint together? Well, the amount of jobs is one house. So this is the third number is the numerator, the other number is the denominator. Third number is the numerator, other number is denominator. So working together, we add up these rates and we get 5/24 to paint one house. So it's equal to 1 over 5/24, which is equal to 24 over 5 or 4 4/5. Okay, so there we have it. Here's another way, step by step for you. And it shows you how we can do it on Gizmos. All right, so here we have 5/24. Here we have one job. If we want to do it in Gizmos, we would do 1 over 5/24, and it shows that that's equal to 24/5, which is 4 4/5. That's how many hours it takes. All right, so there we have it for today's class. Hope you enjoyed it. Hit me up if you have any questions. And I'm going to stop my recording.